Welcome to Walkabout the Galaxy, the international astronomy podcast where the science is universal, the opinions are personal, and the sponsors don't pay.
We really got to work on
I
that.
have to figure something out there. We are Strange and Charm the Astroquarks, also known as Josh Caldwell,
And Addie Dove.
coming to you from the Walkabout studio at the University of Central Florida. Up and top are tending to something I've heard referred to as life.
Interesting.
And are not able to join us today. We are delighted to have with us in the studio today Dr. Katariina Nykyri. How close did I get on the pronunciation?
That was pretty perfect, actually.
It was
Yeah.
pretty good. All right.
Yay.
Katariina, professor of physical sciences at Embry-Riddle University here in Florida. Welcome to Walkabout the Galaxy.
Thank you, Joss and Addie, for inviting me.
Remember to subscribe to us on all platforms, including YouTube, Facebook, Twitter, and Instagram. Check out our MegaCon 2022 episode and our music video and past episodes on YouTube. We are also at www.walkaboutthegalaxy.com, where you can see how to order a Walkabout shirt and support STEM education at the same time. You can contact us anytime at wtg@ucf.edu, and definitely do contact us that way if you order a shirt, so we can actually send it to you.
Someday we'll take shirts to conventions with us.
Maybe.
We could have giveaways for the audience.
Yeah, we should probably do that. We are going to
Get
another
stickers.
convention. We had a great time at MegaCon,
We did. It was
which
fun.
specifically prohibited stickers.
What?
Yes, because
Why?
somebody might take that sticker and stick it on something.
What's
That's
that
the point
for?
of stickers.
It's like gum at airports,
Oh,
right? You know,
that's
they
true.
don't sell gum sometimes at airports or
Oh.
something because it ends up being a horrible mess.
Oh, that's too bad.
So MegaCon didn't want us to have stickers, but we are
That's
going to
lame.
Dragon Con in Atlanta.
We'll see what their rule is.
Yeah, so
You're gonna dress as a dragon, or?
what are you going to go as?
I haven't decided yet. I would like to wear a costume.
You're going to do some cosplay?
I'm going to do at least one cosplay, and it might be something that involves both me and Riley.
That would be fun.
Yeah.
Can she be Grogu?
She could be Grogu. I kind of want
And
to
you
do...
could be the Mandalorian, but
That's
nobody would
true.
know it's you.
That's true. I might do something else, but I have thought about that.
Yeah.
Or I could be Grogu, or she could be Grogu, and I could be
You could
the
be-
lady with the other Jedi lady.
Oh, you could be the Jedi lady with
Forget her
whatever
name.
those things are that come out of the head.
Head tails? I don't know what they are.
But what about the David Sedaris' sister's character?
Oh yeah.
Yeah,
She's,
Amy
she's
Sedaris.
quirky.
Yeah. On do you watch
The Mandalorian.
Star Wars stuff? Did you see The Mandalorian?
Yes.
You know who Grogu is?
The
The
child.
Baby Yoda.
Baby
Oh,
Yoda.
Baby Yoda, yes, I
Yeah.
know that one.
Yeah.
Yeah.
And if
He's
you
super
were
cute.
if you were going to go to one of these conventions, what would you dress up as?
Probably as a Jedi Knight.
A Jedi
I like
Knight?
it.
Yeah.
Yeah.
Anyone like a Rey Jedi?
Ray.
Rey,
I have
yeah.
hair for Ray.
Oh,
You do.
that's
Yes,
true.
you
Yeah.
do.
That'd be
Yes, you
fun.
do. Yeah.
Yeah.
Well, our stumper today is meteorological, and it's meteorological in honor of you, Katariina, because in your many scientific pursuits, there's a space weather component, but we all live on,
Which we'll talk about later.
which we will talk about. So the question is, space weather or tropospheric weather?
And to the layperson, tropospheric weather is just also known as weather.
Right. Well, yeah. So, yes. Fair point.
Colloquially called weather. I am going to go with space weather
Okay, why?
because it's interesting.
Yeah.
And-
You don't think like hurricanes and tornadoes
I
are
do.
interesting?
It's almost hurricane season here, and I do. I mean, I do love hurricanes and tornadoes. I don't love them. I'm fascinated by them.
Yeah.
We've had some tornado warnings lately, and I don't love that.
We also have hurricanes and tornadoes in space.
Exactly.
Oh,
Yeah.
really?
Yeah.
Hurricanes and tornadoes in space? Will you
Correct.
tell us about that when we're after?
Sure,
Okay,
yeah.
when we get to that. Okay.
Yeah. But
Right.
space weather is like, I don't know. It's
Okay.
just different. I like it.
I'm
It's
guessing you're
interesting.
going to say the same thing.
Yeah. Do you prefer space weather or weather?
Well, I think the space weather is a little bit easier to deal with in a
Ah,
regular
that's
basis,
true.
but we have to be mindful about that if we want to do something big and do it safely. You know, then
That's
we have
true.
to.
But which is more awesome?
Yeah, which is
Oh,
more.
space weather, of course.
Space weather, of course, is
Yeah.
more awesome. Well,
It is more dangerous for like satellites than weather is.
It is. The reason I said tropospheric is because, and you can help me understand this, is like space weather is some kind of interface with the atmosphere. And so there's like, I don't know where space weather ends and weather begins, which is why I said tropospheric, which is the bottom of the atmosphere.
Okay.
Actually, in places like Mars, that's kind of like the perfect
same thing.
continuum. You know, it kind of like continues all the way
Yeah.
potentially from the space weather to the dust storms and the
Yeah.
tropospheric weather.
Yeah. Do I detect a hint of an accent?
Maybe.
Maybe.
It might be a combination of the Finnish and English and Alaskan.
Oh,
Okay.
Alaskan.
Yeah. Anyway, we're glad to have you here. You're going to tell us about space weather and, as it happens, Martian weather. Although I
Yeah.
wasn't thinking about a space weather component in the Martian weather. But first, this episode of Walkabout the Galaxy is brought to you by tea.
Nah.
Coffee can give you that high-octane caffeine bump, and hot chocolate has that creamy, sugary decadence. But if you need a comforting, warm beverage without all the fuss, maybe it's time for tea. Combining such tea varieties as the Large Millimeter Telescope Alfonso Serrano, or LMT, in Mexico, the James Clerk Maxwell Telescope, or JCM-T, in Hawaii, and the IRAM 30-meter T in Spain, tea uses its perfectly balanced mix of teas from around the world to provide a uniquely revealing flavor that's sure to transport you on your walk about the galaxy. So look for tea by our name brand, EHT, and discover the heart of your galaxy.
Aw.
Tea can do that.
That sponsor must have been so inspired by recent events with discoveries, the EHT discoveries.
Yes,
Yeah.
yes. I ran that sponsor by some of our devoted fans who thought, no, too obscure. And Katariina's probably going, what have I gotten
What's
myself
happening?
into here?
What
Yes,
is
what is
happening?
happening?
Can you say the tagline again?
Tea can do that.
Tea
And
can do that.
Tea can do that. So
So-
somebody actually has that as their tagline.
Yeah,
Your challenge is
to figure out who it is. Tea can do that. Is it like Lipton?
It is exactly Lipton.
Yes.
Not only is it
Oh.
like Lipton, it is Lipton.
Yes.
Yeah.
I'm
So-
glad. I was like, do I go with just a
Something
really standard
obscure
one,
or something basic.
like
Yeah, I figure.
celestial seasonings?
Tea. I was thinking about celestial seasonings from our hometown
From
of
Boulder.
our adopted hometown.
Do you remember the
hometown
mint
Boulder.
room?
Yes, in Boulder, Colorado, where they make celestial seasonings herbal tea. Have you been there?
Where?
To Boulder?
I've been to Boulder, yes.
Yeah. Have you
Yes.
been to the celestial seasonings tea
I have
tour?
not. No.
Okay.
Yeah, so they have their factory. It's just outside of town, just on the edge of town, and they have a tour that you can take.
Mm.
And on the tour, they go to like all the different areas where they process the tea and process different things. But then there's one room they take you into, and it's called the mint room.
Mm.
And they have to like keep it. It's a sealed room that they keep separate from everything else because mint is so pervasive
Aromatic.
and
or
aromatic
something.
that it'll
Yeah.
just like contaminate everything.
And they
so-
have mint like in all of their.
Oh,
There's some
okay.
amount of mint
Yeah,
in so many of their herbal teas.
Yeah.
This is an astronomy podcast, right?
it is.
Okay,
yeah.
just double
But
checking.
you go in there and you're just like your eyes almost water and you feel like
It's-
you're brushing your whole face with toothpaste.
It's, yeah, it is. It is eye
So
watering.
intense.
It is literally eye
Yeah.
watering. Yeah.
It is not tea. It
No.
is whoa
Whoa,
tea.
peppermint.
Peppermint. Anyway,
Space news: Starliner just landed.
it did.
And
Yay.
it's a landing,
It
not
landed.
a water
It was
landing.
a land landing. Yeah.
At White Sands.
Yeah. It descended on some parachutes and nicely set down in the desert. It was a very nice landing, which was nice because almost every other step of their mission
Had
had
some
little
little things.
hiccups along the way. But I
Yeah.
think that one went pretty smoothly.
They land on
Yes.
airbags too. They've got airbags.
Oh yeah, that's great.
So the Blue Origin suborbital thing does a sort of little blast of gas right as it's
I'll stop.
right as it's landing, and but this one actually has like just inflated airbags
Yeah.
that it sets down on.
Yeah. So that was exciting. And so they're going to analyze all the data from the Starliner mission, and
In principle, launch with a crew later this year.
yeah. I think the mission went. There were little hiccups, but overall it went well. And I think they know what some of the issues were.
Right.
And so I think that they're probably going to be able to address those and proceed with the crew launch
Yeah,
later
that'd be
this year.
exciting. Yeah.
So exciting.
Have you been enjoying? You mentioned you're originally from Finland. Now
Yeah.
you're living on the space coast of Florida. Do you go see rocket launches?
I see them sometimes, from Daytona Beach, but definitely when we still had the shuttle, I definitely always drove here to watch the shuttle launches.
Right.
And I saw the last shuttle launch in 2012, and also the Atlantis pullover when we moved it to the Kennedy Space Center. So I have this awesome picture when we had a bright blue sky and we were pulling the Atlantis there. And then you had the river, so when you took the picture of it, it actually had a reflection. So the coast of Atlantis is brilliant.
Nice.
That's super cool.
Yeah.
I never got to see a shuttle launch. We did when the was it 2 nights ago? Yesterday, the transport. There was another SpaceX mission, transporter or something.
Right.
And their booster they also landed on land just yesterday or the day before. And when they land on land, we get sonic booms, and we heard it all the way here in Orlando.
I totally missed it.
I was like, "What was that noise?" And I was like, "Oh yeah, sonic boom."
I grew up in Central Florida in the early days of the shuttle program, and that was I shouldn't say frequent occurrence, but how many shuttle missions there were, 100 and some. But yeah, that frequently boom boom, and it would where I lived, it was quite loud where it came over shuttle landing.
And I was very thankful for NASA. I got a nice ticket to watch, from the launch site, the Parker Solar Probe launch and also the Solar Orbiter launch. So that was amazing just to count down, and there are millions and millions of dollars of equipment there. Please don't blow up.
I know, it's so stressful, even if it's not your spacecraft, right?
Right, because you're very interested in the data that's coming from that mission, Parker Solar Probe.
Yeah. So many people spent so much time building it.
Yeah.
60 years in planning, and now we have a technology to kind of to make it happen. To sustain the heel so close to the sun, the hottest place in our solar system.
Right. But first it has to launch.
Yeah. I remember. So the Cassini. I was on the Cassini mission, and that launched a long time ago, and that was also. I should have been more worried about it than I was at the time. I think I was young enough at the time that I was like, well, this blows up. First, it's going to be fine, and second, I wasn't even thinking about the consequences if it didn't. Now, if I look back retroactively, it's like that was the backbone of my entire career. Was that mission, and so I imagine erasing that, my life would have been so different. Speaking of launches a long time ago, we were coming up on the 45th anniversary of the launch of
Voyager.
Yeah. Voyagers 1 and 2. And apparently Voyager 1 is, which is, do you know how many light units away Voyager 1 is?
40 something?
It has passed the termination shock already, a while ago, so it's already in the interstellar space.
Right. 20 hours and 33 minutes of light travel time.
What?
Yes.
I didn't realize it quite that much. I heard a story about that the other day, and I remember that number now, but that's crazy. 20
and a half hours for a radio signal to get from Voyager to the Earth.
That's
then
far.
You got to spend some time thinking about it, and then you send your signal back, and it takes it almost 24 hours to get back there. Anyway, the spacecraft seems to be okay, except that the telemetry it's sending it's
wonky.
Yeah.
It's weird. Yeah, it's like it's sending back data, and we're talking to it, so we know it's
and the radio signal is
pointed the correct direction, but all of the telemetry says that it's not pointing in the correct direction, and so there's a lot of questions about what's going on.
It may have is it aphasia?
Aphasia, I think that's correct.
When
that would be correct.
You're having trouble forming the right words,
or
something like that. So it's not sending the right words back. So they're not sure what's going on, but
it's probably the fact that it's a 45-year-old plus computer.
This is crazy,
and it's still working.
Yeah.
What computers were around 45 years ago?
None. I mean, think about when your cell phone is 5 years old, you're like, piece of no way.
5 years.
It's ridiculous for me to expect this thing to keep working, and that spacecraft is still operating remarkably well.
I think they used to make stuff a lot more durable. I had a TV when I was in university that it was my parents from 1970s, and it worked perfectly. I don't think nowadays if you buy a TV it would last 25 years.
No,
the capacitor would at least blow up.
Yeah, exactly.
Yes.
They don't know if it's radiation damage because it is way out in interstellar space and the radiation environment's way different, or if it's just because it's old.
Galactic cosmic rays coming there and not protected by the heliospheric bubble, the magnetic fields.
Yeah. Well, we'll talk about magnetic fields now, actually. So
Great.
So
don't look at me. I'm just kidding. I do know what magnetic fields are.
I don't think I do. I talk
Oh.
about them a lot, and I know how to do calculations involving magnetic fields, and I know some of the things that they do, but they make me somewhat
Does anybody
uncomfortable.
really understand magnets?
They
How do
make
they
me
work?
somewhat uncomfortable. So we were talking earlier, Katariina, about some of your research and made
Sure.
references to you being a space weathery person. Is that a good description of your area of research?
Yeah, I think space weather is more like a more easier word to say. It's the official word is space plasma physicist. But space weather is more like that's the what follows from all of these complex plasma physical processes. It creates certain weather conditions in space that we want to avoid, but in particular we want to be able to predict them.
Yeah.
So that's kind of like where my research falls in.
And we want to be able to predict them to understand how they're going to impact Earth, how they're going to impact satellites that are in orbit, things like that. Yeah.
Or to keep our astronauts safe on the way to Mars or to the lunar surface.
Yeah.
So what are some of the particular areas that you've been studying in this area?
Sure. So my main interaction is to kind of like understand the detailed physics, what happens at the boundary of our magnetic shield. So we are very lucky to be born in this planet, or we wouldn't be born in this planet if we didn't have a magnetic field. So the Earth's magnetic field is created by these giant currents that are rotating around our core, and then towards the dynamo we create kind of a dipolar field, which is similar to that of the bar magnet, and that kind of like protects us, from the solar energetic particles. And however, there are regions in that shield, I call it our magnetic shield, where we can get kind of like a breaches on that shield, and the solar energetic particles can get through. So that's kind of like what I studied also.
I like that imagery. It's very sci-fi also, because that's what
The
we always
shield.
The shield, yeah.
Yes.
We always describe it
Ray
as
shields.
the Earth's magnetic field, but I like it as Earth's shield. Yeah. Because then you can picture like little particles hitting the surface and it glows like when it does inside.
I wonder if when the Enterprise raises its shields, if they're turning on some gigantic electromagnetic generator or something like that.
Definitely important. Like if we want to go safely to the Mars and we have like a solar energetic particle storm coming, how do we shield ourselves? So one of these ideas there could be like generate a magnetic field around the spacecraft to protect us, similarly like now our planet is doing naturally.
Yeah.
Okay.
Interesting.
So there were a couple of things you said I wanted to go back to. So one, we do love the Earth's magnetic field, not just because it keeps us alive, but also
Have they been a sponsor?
Oh, that's a good question. I'll have to reach out to them. Yeah. But one thing that we love is that the Earth's magnetic field, you mentioned the dipole, sort of like a bar magnet, right?
Sure.
So there's a north magnetic pole and a south magnetic pole. And the south magnetic pole is at the Earth's north geographic pole, or near it, right?
Yeah, correct.
But it's also recently been moving and more quickly. It's accelerated in its motion, and that gets us or at least me, very excited about these magnetic reversals, which happen sometimes historically. What's up with those? And do you think we're due for one?
So I think that those happen quite infrequently, luckily. So usually every 500,000 years. So scientists have been able to figure this out from the volcanic rocks and to be able to see how the dipoles have reversed.
So the rocks have some sort of they as they solidify, they record the direction of the magnetic field.
They want to align themselves with the dipole direction, basically. So the interesting thing about that is that when that reversal goes through, momentarily our shield goes down, and we are kind of like full, like
shields are down.
Shields are down.
Full of these mini little cusps, like the solar magnetic field. And that basically gives you direct access of all the solar energetic particles and radiation directly to the Earth.
That's when the Klingons uncloak and attack you.
That's right. Yeah, when your shields are down and you're recharging. So now we have the other thing we talk about frequently that is the aurora. Right?
And those are also caused by those.
Which is so those particles are solar originally, yes?
So they can be both. So we have a component for our plasma. We call it plasma, all these energetic particles that produce these beautiful end results like aurora borealis. So some of them come from our atmosphere. They go to they can escape the atmosphere into the space, and then they will be trapped. And then they can get back to the atmosphere by these acceleration processes, like a kind of a slingshot sometimes, that our dipole field can get extended in the night side of the planet. So it becomes kind of like a tail. Like if you think about the rubber band and you extend that very long, you have all that energy stored in that rubber,
yeah.
and then suddenly you can't keep that tension anymore, and it just comes and springs forward, and you can shoot a stone or something like that forward. So similar things happens in the Earth's magnetic field.
Okay, yeah.
So when we have this kind of like an interplanetary magnetic field merging in front of our shield, it kind of opens up that shield and tracks that field in the night side, in that long tail, and accumulates that energy there. And at some point it snaps and it brings the field back earthward, and that's when you launch those energetic particles. Some of them solar origin, some of them ionospheric origin from our planet, and they come and they can then hit the atmospheric atoms and energize the electrons in those atoms into higher energy state.
And that's when we get the aurora.
Aurora, correct.
Okay, so the magnetic field, so the Earth's magnetic field, which is the shield, sorry, the Earth's shield, is generated by some sort of dynamo process in the interior of the planet, and it's somehow a kind of a stretchy thing. To stretch it requires energy.
Correct.
So when it is stretched, it is storing the energy.
Correct.
And one of the things that can stretch it is the solar magnetic field,
Correct.
essentially, the interplanetary magnetic field, which originates in the sun.
And the momentum in the solar wind,
That carries that field because charged particles tie themselves to those magnetic field lines. Okay, so then that's a kind of, to me, that's kind of a space weathery thing, right? Some solar activity, and if you had a lot of particles coming from the sun, would that enhance the coupling of this interplanetary magnetic field with our magnetic field?
So we are particularly, all these space scientists get particularly excited when we have something called the southward IMF. It's when the...
Wait a minute, sorry, the southward what? IMF?
Southward interplanetary magnetic field. It's because the shield...
I'm sure you get very excited by that.
The field, it's in my voice.
Calm down.
The magnetic field in the Earth's shield is pointing northward, and then the magnetic field in the solar wind, sometimes it points southward. So when you have kind of like anti-parallel magnetic fields, that's when they can cross, and you can have this kind of like a solar wind highway of particles getting, it's kind of like an intersection into the other road. And that's when you can get that coupling.
These what are called X points?
Yeah, like a magnetic X lines.
Okay.
So that's where the reconnection happens.
Okay, and so this is totally a great movie idea, right? Because this is, I totally feel like the MCU should tap into this thing, because they love things like you got a northward field and a southward field. If they
don't cross the streams.
Yeah, that's right, exactly. The universe will explode. Or aliens from some other distant realm are going to come invading.
Exactly.
So when you talk about the aurora and kind of like the negative effects that when we lose our shield, the dipolar field, the very positive thing about that is that, you know, before you have all the negative consequences, you could be somewhere in the equator and what's the aurora? So you could be in a beach, you know, in a warm weather, and what's the aurora borealis? Nowadays, you usually have to go into cold places like Finland or Alaska, be freezing, and then you can see the aurora.
Were aurora a common sight for you growing up in Finland?
Yes, so I was born like in western Finland, then we moved to eastern Finland and to north, and finally to south. And but it's really cool thing when I actually graduated from Fairbanks, Alaska in 2002, and I was holding my like a PhD, like a party for my friends and relatives in Helsinki. It's not very typical to see like aurora in Helsinki because it's so much south. And then my one of my relatives was asking, like, so can you tell me about your research? What are you studying? And then my husband was saying, hey, look up. At that very moment, there was like a crown opening from, it's a very rare aurora, like a crown opening in the sky in Helsinki, and it's kind of like a railroad effect. It's, you see that crown because you look so high up to hundreds of kilometers, so it looks like they're converging like that.
Cool.
When you saw those auroral rays coming down.
That's awesome.
And that was like the best graduation
present.
Yeah, for sure.
That's
You're like, what are you studying?
awesome.
Oh, that.
Yeah, and it's a pretty
cool.
awesome thing to look at. You know, like for me, if I were lucky, I would be able to say that little dot of light up there if I was lucky.
Or the moon.
Or well, the moon is pretty cool. You had a better one to point out for the moon.
You studied the moon.
I did study the moon. So I'm actually curious about, so what is the altitude range for aurora?
So it usually starts about 100 kilometers like upward, and you have that's where you have like I think most of the aurora, and you have different colors depending on the emission. And they mostly occur at the quite in high latitudes, but when we have like a very intense storm than that auroral oval region. It comes to the lower latitudes.
Yeah.
Like in 1856 when we had the Carrington event, that's when the aurora was visible, like even in the equator and on the telegraphs went into a fire and everything. So so now we have been lucky to avoid any like a Carrington scale events, but we have had like at least one nearby miss. So there was a big coronal mass ejection that left the sun, but it missed the Earth.
That would have been really bad.
So
in Colorado sometimes it was like just barely visible, but it was always cloudy.
It was.
There was like two times when I was there that it was maybe going to be visible, but it was always cloudy.
It's similar. We didn't ever overlap. We overlapped briefly in Colorado, but so a whole year actually, academic year. But in any event, so 100 kilometers. That's the altitude that some of these suborbital tourist spacecraft go, like Blue Origin's New Shepard and Virgin Galactic. So if you were on one of those and launched, say, from Alaska or Finland or someplace, underneath an auroral display or event, would you have a very different view? Would it be a very different sort of experience viewing it from a spacecraft, sort of for a few minutes being up kind of near that auroral altitude? Like, what would that viewing geometry do to change your experience of it?
So that would be really amazing. Like the very active aurora, it's very dynamic. It's like rapidly dancing. It's like nothing you have ever seen before. So when you look it from the ground, you still see all the displays there in the sky. But there's amazing structure. So sometimes you can see almost these like auroral tornadoes coming down all the way, and you can see like really a tornado, but it's made from the emission of the electrons. So being in the eye of that tornado, like with the, that would be amazing. But I'm sure there's a reason why they don't launch them from the light.
Well,
there's sounding rockets that launch.
Right.
So people study those, right? And they do try to launch sounding rockets during some of these events.
I think the reason for the moment that the tourist flights aren't going from there, I mean, maybe there are some other reasons, but for the moment it's just like they're still trying to work all the bugs out.
Right. Here in Texas.
They just got to get things working.
How much radiation we would get from those flights?
It's worth it if you're just doing it once.
For a few
worth
minutes.
it if you're just doing it once for a few minutes.
Totally. Like I wouldn't be like a couple of chest X-rays.
Oh sure.
That'd be fine.
Yeah. What's a chest X-ray here or there? Yeah. Well, our trivia is space weather related. So this is all in your honor. So no pressure. We've been talking about space weather, ultimately driven by the sun, as is normal weather, or weather, as Addie would say.
Just weather.
But it's usually particles from the sun instead of photons that are responsible for space weather.
For trivia, we don't answer right away. We think about it, but then we come back to it.
So it takes light about 500 seconds, 8.5 minutes or so, to get from the sun to the Earth. What is the fastest Earth-directed coronal mass ejection on record?
I know.
Oh no, I'm gonna lose. Like she's probably gonna know this one.
It's probably also a different answer than what I have written down.
That's true.
And I'm sure she is right. I'm sure whatever answer you say is going to be right. So you're
within 20% at least.
Yeah. So I have my answer not in velocity, but in the time it took to get to the Earth, so we can figure that out. That's the first one. The second one is about sunspots, which are a prominent visible indicator of solar activity, and they follow this famous 11-year cycle. This is multiple choice. When were the earliest known drawings of sunspots made? And these are your choices. 800 BCE.
Oh wow.
165 BCE.
Wow.
The year 1128.
AD.
Yes. The year 1543.
AD. That's my initials, so I like saying that.
Oh, okay. The year 1610. Handy dope.
AD.
Or 1643.
AD.
Okay, so we'll come back to those choices again. So, and then
that's a really big time range.
It is a big time range. And the last question is going to be the size of the largest sunspot group based on photographic evidence and when that was seen. So we'll come back to that, but now we're going to move out to a different kind of weather on our
Mars.
next door neighbor.
Dust. We're going to talk about dust.
One of Addie's favorite topics.
So we actually mentioned a dust on the last podcast, Mars dust, because
it's doing some nasty stuff.
It's the reason
Insight
was gonna say ingenuity, but that was wrong. Insight is maybe gonna take a long nap soon.
A forever nap.
A forever nap, probably. Yeah, so we know, so Mars for a long time we've known has these big dust storms, and they have big global dust storms, they have localized ones, they have little dust devils that scurry across the surface.
Which I think are the coolest thing
Which are
ever.
super cool. But we have like video basically of dust devils scurrying around down there.
When it was maybe Spirit, I think Spirit and Opportunity first showed these movies of dust devils on Mars.
Yeah.
And I was like, oh, because I'm not really a Mars guy, I have to confess.
Yeah.
But when I saw that, I'm like, that is cool.
And they're interesting scientifically, they're interesting just like observationally, but they're also really useful for, it turns out, helping clean off the solar panels on our little rovers.
Right.
So like, they have these pretty high velocity little winds that just help sweep off the dust, which has been pretty useful actually for a lot of our little rovers, but not Insight. It's in that really sort of, it's down in a little hollow area without
it's not windy enough
devils.
or something.
It's not windy enough down there.
Yeah. So there's been several sort of long-standing questions, I guess, about the origin of the dust in Mars.
Yeah.
Like, where is that dust coming from, and how is it happening? And apparently, as it turns out, you mentioned Insight that obviously has pictures of dust accumulating on its solar panels, but it doesn't have. It's not seeing dust devils, so it can't really measure those. Up until Percy, there's been either rovers that like see dust devils but can't measure the wind, or ones that can measure the wind but don't see any dust devils for whatever reason. Now you've got
Curiosity had like a weather station, and they had cameras, but their weather station couldn't do kind of the level of measurement we needed, and it actually was damaged during landing. It hit with a rock that was thrown up during landing, so it wasn't able to get all the measurements it was hoping to get.
Oh, okay, I didn't know that.
Yeah.
So Perseverance, the biggest, most recent U.S. rover, has all the right pieces. It has ability to measure wind speeds and great cameras, and it can track all this stuff.
Wind speed and like pressure, which is important for understanding. Like atmospheric pressure tells you a lot about like how easy it is to lift dust, for instance. Like it's.
Yeah, so I had never really appreciated how vexing a problem this has been to understand where is all this dust coming from. So it turns out Mars has, you mentioned global dust storms, apparently it has on average about 3 per Martian decade.
The global ones? And they usually last like
months, right, I think?
Yeah.
Months or an Earth year or something like that. But the atmosphere is always dusty at some level. At Mars.
It's always a little hazy.
And
it's like when we get our Saharan dust storms and your atmosphere is a little bit hazy.
We get some dust comes over, sand or something. There's sand and dust, or people draw a dividing line.
Those are very different.
Yeah. And that's actually apparently one of the critical things here. So the Mars has less gravity. That's good for getting stuff up off the ground. Has less atmospheric pressure. Bad for getting stuff up off the ground. The atmospheric pressure on Mars is about 1%.
I'm gonna break into cold sweats right now during my oral,
during
my research candidacy, my oral candidacy when I was getting my PhD, like for my master's, right? I got questions about like velocities and how much, like what sizes of dust could be lifted and stuff like that on Mars.
Okay.
And I had to like calculate in my brain in situ, and and I'm not as good at that. So anyway.
But from
what I did an okay job.
From what I'm reading, probably whoever was questioning you was probably full
also
of it
wrong.
because it seems like they don't still really understand this stuff very well.
So I wonder, like, because in the Earth, tropospheric climate, we get this like a kind of a long-term weather behavior, like the El Nino and El Nino kind of thing. So I wonder, like, if the Mars, that doesn't have oceans, but it could have still these like long climatological patterns that could be driving these global dust storms that, you have to have a certain condition, but maybe those are more like a still relatively periodic conditions, I don't know.
Right.
Yeah.
Or do we have enough time scale measurements in situ at Mars to be able to tell that yet?
Well, we have enough times, like, yes, I mean, I think for like the global scale stuff we do, because we know a lot more now about sort of the cycling of like how large the polar caps are and how those grow and shrink, right, which influences how much gets into the atmosphere. But I think for the dust, like knowing the sources and the sinks and like what those patterns are, I think it's been a lot of the question for a while. But there definitely are those seasonal patterns, or those not seasonal, but
Periodic.
periodic patterns, because we don't see dust storms all the time.
And seasons are more extreme on Mars because its orbit is eccentric and it has a tilt about like the Earth's tilt, which is the source of essentially all of our seasonal variation. But on Mars, it also has a pretty significant variation in how far away it is from the sun. So that affects some of what's going on. And the atmosphere is so thin that the atmospheric pressure changes significantly in a fractional basis, just from daytime to nighttime.
Yeah.
And then also when you put dust in the air, that absorbs sunlight, that heats it up, that causes the atmosphere to poof up and expand. So there are all sorts of interesting feedbacks.
Oh, so MAVEN will get some interesting measurements.
One of the Mars orbiters.
And it's studying the atmosphere and like charged particles and things like that too. But it'll get, if the atmosphere poofs up differently, it might get some interesting measurements.
I guess you wonder also, like, is there any correlation with the solar cycle as well? Like when we have a solar minimum, a solar maximum, that's the space weather coupled with the tropospheric weather at the Mars. Because we know now that, for example, these giant space hurricanes that we have at the Earth that breach the Earth's magnetic shield. Like one of them is the Kelvin-Helmholtz instability, like you may see sometimes when two rivers are intersecting, you get this giant vortices.
Oh yeah.
At Earth, those can be easily like 20,000 miles in wavelength.
Oh wow.
So we just did some research work with Dr. Kankao Po in NASA Goddard, and we found that the same phenomena happens at the Mars, and it can actually take Mars's atmosphere with it and release it to the solar wind. So that's why I'm wondering, like, if that could, when we have a certain space weather conditions, because those can produce like currents that are all the way can couple, form that kind of like ionopause deeper in. So I wonder if those can play any role in it.
Probably.
Sure.
That's cool.
I don't know.
And so some of the other things that haven't been known is like, okay, where, in fact, I mean, just these same questions you were asking. Is it space weather? Is there some global scale, periodic, annual, or some other fluctuation going on that's driving things in analogous in some sense to El Nino here on Earth? So at the Percy rover, which is at the Jezero crater, has all the right combinations because it's got wind and it has dust and it has these upslope of wind and stuff like that. So they've seen two kinds of things. There's something called gust lifting.
Gust lifting?
Gust lifting, yes, which is different than the dust devil business.
Okay.
So I learned a lot when I was reading through this stuff, which just illustrates my ignorance going into reading about it. So they have convective cells that are several kilometers across, and the dust devils are vortices that spin off at the corners of these convective cells.
Okay.
And they're very common, and they get a lot of dust in those at this location. But they've seen several big gust lifting events, which is just like kind of when you think about sandstorms in the movies, like The Mummy or something like that, where there's this huge sandstorm coming across. Okay, that's right. Yeah.
Haboobs is what they're called, giant sandstorms.
Maybe that's the title of this episode.
Martian haboobs.
Okay. And so they've seen those happening as well, and it seems like that they can both be significant contributors to putting a lot of dust in the air. There you go, some nice haboobs.
Oh, wow.
If Jim were here, he'd be giggling like a maniac.
I know.
And so
Arabic from blasting and drifting.
Blasting and drifting. So one of the questions, like, okay, how fast the air have to be moving? The questions that you got, time for your cold sweats.
Oh God.
How fast the air have to be moving for it to knock stuff off? So you would think.
And what size particles will it knock off?
One might think you knock off the smaller particles easier, but you don't, because they're stickier.
Yeah, it's going to be bigger particles. There's going to be some
the
in-between
bigger particles, there's the magic size.
Yeah.
It's sort of like in planet formation, I think about, there's the meter barrier.
Yep.
There's the magic size that's most strongly coupled to the gas. In the protoplanetary disk, it's a meter. In Mars's atmosphere, it's like 40 microns or something like that.
Yeah, because the tiniest stuff.
Or something.
40 microns is still pretty close.
Yeah, I don't know. Anyway, that number may be wrong. So
Okay.
But there's a
the
same
tiniest
size.
stuff, right? We know this from everything we do. The tiniest stuff is going to stick really well.
Right.
And the big stuff is going to be hard to lift because it's too big, but there's going to be some in between size.
Right, where the surface to mass.
Got a wild idea. we have an excellent wind tunnel in Anniversary where we're testing aircraft. Why don't we test this in a
Yeah, that's so good. You can stick little.
How big is that wind tunnel?
Oh, it's like over 10 meters.
Wow.
Are they gonna get mad if we put dust in it?
Probably like 50 meters. It's
Sometimes
big.
people get mad when you put dust in stuff.
I'm
yeah.
sure they would be mad.
We do.
Okay.
Yeah, we have a tendency to mess things up.
We can
A lot
talk to
of
them
a
about
lot of
that.
this
I
research
like
has
this.
been done with wind tunnels, like at NASA Ames.
Oh,
they
yeah, they
do
have big
a
wind
lot of
tunnels
stuff there. So it turns out that from the observations made by Percy, it looks like there's sort of a threshold speed of about 15 meters per second for wind speed, which is about 34 miles per hour.
Okay.
And that
Pretty fast wind speed.
it is a pretty fast
Wow.
wind speed. What they have seen is that typical daytime winds are a little bit slower than that,
Okay.
up to about 10 meters per second, which is still a pretty big
Windy.
gust, but again, very thin atmosphere.
Yeah.
And at night, much calmer, less than a couple meters per second. Some of the other things you have to take into account. Oh, well, I just wanted to mention this word because it's fun, saltation.
I like the word saltation. It's fun.
Saltation?
Saltation. So
Or if you
Something
get,
that's salty?
I think it's like a similar root. So it's like basically like things get like little particles get lifted, but then they sort of like bounce
yeah.
along because they're
And
like
you
not
get it-
fully lifted. It's sort of like when you're, I don't know.
Well, you can get almost sort of a runaway. So part of
Yeah.
the problem is you have a wind blowing over. It has to be able to break.
Cold sweats right now. Just kidding.
It has to break the whatever force is holding a particle to the surface. So that's going to be
Mhm.
gravity plus any interparticle forces.
Yep.
Once you do, if you lift that particle up, then it follows some sort of trajectory, some wind-aided ballistic trajectory, and it re-impacts the surface. When it re-impacts the surface, it's an impactor.
Yeah, so it
And
can
then
knock
it can-
more stuff off.
It can knock off a whole bunch of things.
Yeah.
Chain
Which-
reaction.
You get
Yeah.
exactly.
So you
get
get
it.
more small stuff
That's
lifted
right.
up after
Right,
that. And
yeah, and so that saltation process is part of what may enable the tiny dust to
Yeah.
get, so you can lift the magic size, you were talking about the sand,
Yeah.
then the sand particle hits the dusty stuff and liberates the dust,
Oh,
and
and
then
then the
that-
runaway.
and then you get your dust storms.
Runaway dust storm effect. I may or may not have done an interpretive dance of saltation in the Utah desert once in my life.
Were you on something?
No, I mean I was on a geology field trip.
Was that the dance your PhD?
It should have been. No, we did geology field trips in grad school, and we were passing the time describing different
You did an interpretive
transport
dance of
effects,
what?
saltation,
Of
and
saltation.
other like dust transport effects in the desert.
That's
I wasn't the
amazing.
only one doing it. I'm not that creative, so.
So was it a team effort, or was it
There
a
were
bunch
several of
of
us doing
bunch
different parts of the dances and different types of things. So you have like saltation, and I forget all the other things you can have. Is your brain just
I can't overload right here right now. I'm like, something has to happen here. I don't know what it is,
Oh,
but
we'll make
something
a
has to
TikTok.
happen.
We'll make a TikTok of
There
it.
you go.
Yeah.
Okay.
I have experimental evidence that the space scientists and physicists in particular are very good dancers. Like something
Oh.
about getting out of our brain into our bodies and the
Okay.
motion.
I don't know if that's generically true.
I am. So you're a good dancer. You're saying.
Maybe.
Yeah.
At least in my own mind. That's what matters.
That's what matters. That's all that
Okay.
matters.
All right. Well, then, in reality, as well as in my own mind, I am a terrible dancer.
Perfect.
Probably a terrible scientist too.
No.
So let's then come back to your trivia question. So
Okay.
we'll start with the one.
Wait, did we get an answer then? Is there an answer?
Well,
I don't
the
know what the
yeah.
question or answer is.
So
of these
yeah,
Mars
so
storms.
the answer. So there's lots of things that control these dust storms on Mars. You have to take a look at convective processes. We didn't mention it, but there's global circulation cells on Mars, like
Yeah.
on Earth. In each hemisphere, there are three what are called Hadley
Hadley cells.
circulation cells. There's global level circulations like that on Mars, and those vary a lot because of Mars having a thin atmosphere and an eccentric orbit
That's from
and the tilt.
Day-night side, kind of like the inequality of the heating of the day side versus the night side.
Right,
Yeah.
and there's thermal tides on Mars, which also have to be taken into account. But the one answer is that 15 meters per second looks sort of like a threshold.
Okay.
Another is that gust lifting does happen,
Uh-huh.
and while it's much rarer
Saltation.
than dust devils, it is much larger and
Ah,
therefore
okay.
may be a comparable sort of contributor to
So this can help us
the
predict
origin
better
of dust
dust
storms.
storms and understand them. Okay,
Yeah.
cool.
talking about cold sweats, and oh man, I'm getting grilled on the podcast. Okay, so Katariina, you're going to tell us the answer first for the what is the record time for a CME?
So I think that's about 3,200 kilometers per second.
And how long would it take to get here? I got to figure that out. 3,000. So we're 1.49 times. We're 149 million kilometers. Do you know? You said 300,000 kilometers per second.
So 3,200 kilometers per second. So if it takes from the speed of light about 8 minutes, so then you can figure out the distance because the speed of light is 3 times 10 to the 8 meters per second. So
there's too many numbers jumping around there. So do you know how long it would take roughly?
So
because that's what the answer has to be in units of time. I'm sorry, that I can't. That's what's written down here.
You want to change that, in the
you can't Google your answer. No, I want it in minutes.
She was going to calculate it.
Minutes. So minutes, then I would say it's closer to about 50 minutes.
50 minutes?
Yeah.
So.
Sorry, not 50 minutes.
So that can't be right.
Sorry.
That would be 10% the speed of light or something like that.
I was thinking from the from the regular solar wind, it takes about
3 or 4 days or something.
Yeah, 4
right?
days. But now this is like much faster. So
like
2
times
solar wind
fast,
is
right?
400 kilometers per second. So this is now about 10 times faster. So if we divide that by 10, so.
Okay, so you would say like half a day or something?
Half a day, roughly.
Yeah. The answer I have written down is 14.6 hours.
Okay.
Which is a little bit slower, right, I think, than what you said. So I'm sure your answer is correct, though. We didn't even give you a chance to answer.
You didn't give me a chance. That's fine.
We should have had you guess first.
I know.
I don't know why I didn't do that. I'm sorry. You'll do this one first.
So it took
14.6 hours instead of a typical speed of like 4 days.
That's scary.
That is scary fast.
Because most of our contingency plans that we don't really have, but ideas for contingency,
plans, if we had it, we wouldn't even have a chance to deploy the plans we don't have.
Yeah, you see a CME and you're like, oh no, we have to go do something.
Yeah.
What we can do is turn off all our satellites and prepare for the darkness and
hunker down.
Prepare our teenagers for time without internet for
a week.
Oh
God.
A week without internet. Yeah.
What is
like
this?
the
1990
or something. Yeah. Okay. When were the earliest known drawings of sunspots made? Your choice is 800 BCE, 165 BCE, and then 1128, 1543, 1610, or 1643.
I'm gonna say 1610 after Christ.
Telescopes or something.
Okay.
1610.
1610.
I'm gonna say the 100 BC.
165
Yeah.
BC. So all those numbers are based on something.
I figured they were.
Right. But the 1128, John of Worcester chronicle, and he made a very sort of fanciful sketch and a mention. The next one that after that where there is a drawing.
Yeah.
So the 800 and the 165, and there are other dates going back.
Were eclipses or something?
No, they were reported and written, but not drawn.
Or
if they were drawn,
doing like pinhole camera things, or like what were
no, they would look. Oh yes,
they were just
excellent
looking
question.
at the sun?
They were looking at the sun,
Oh,
but under certain atmospheric conditions where they wouldn't go blind immediately. So a lot of people were looking at them like at sunset or sunrise, or through haze or clouds or things like that.
Oh, okay.
Yeah. Do not look at the sun.
Don't look at the sun.
Unaided, or I mean, without appropriate
just don't.
eyesight protection. So, these have been recorded and mentioned historically, primarily by Chinese and Korean astronomers. The earliest, going back more than 2,000 years, and that gives us some long-term historical record of solar variability. In 1610, Katariina, there was a drawing of the sun, and there's some dispute about who discovered sunspots at that time, even though they had been reported by many people for centuries and centuries before. Who made the drawings in 1610? Do you have any idea? Because I thought I knew the answer to this, but I didn't.
Like Galileo's sunspot drawings are pretty famous, right? Or no, was it Galileo? There was somebody who went blind.
Herschel was later.
Yeah.
He's 18th century.
I feel like when we were at the London, the Greenwich,
Observatory.
I feel like we learned a little bit about somebody who went blind looking at the
Well,
sun.
Galileo did lose his eyesight,
Looking
and he
at the
did look
sun,
at the sun
but it's not
through
the
his
right answer.
telescope, and he reported sunspots in 1611.
Oh,
And
you're off.
somebody else did as well, his name I didn't write down, and they got into a big shouting match about who had discovered them, even though Thomas Harriot had drawn them and reported them in 1610.
Scoundrels.
Yeah, okay, final trivia question is, what is the largest sunspot based on photographic evidence, and when was it seen?
What units are we using?
That's an excellent question,
Great, thanks.
because the units that are used for size of sunspots historically are a crazy unit.
They are.
Do you know what they use?
The size of the Earth.
Well, that you
Yeah.
could use that. The ones that I was seeing are millionths of a solar hemisphere in area.
Oh, what? That's weird. That
It is weird. The Earth is 80 millionths
Okay.
of a solar hemisphere, so you can do it either way. Or you can give me the longest linear dimension in miles. So
Do you know? Biggest sunspot?
I would say it's about 100 Earths.
100 Earths, so what's 80 times 100? 8,000.
8,000. I'm gonna go with
100 Earths this way, or 100 Earths arranged so that
Yeah,
it's
like a
only
circle.
actually.
It's like a diameter, like
100 Earths in diameter.
That's the whole sun. The sun is 100 times the Earth across, so that would be the whole
Oh.
sun would be a sunspot. The diameter of the sun is 100 times the Earth.
Is it? I always forget
Yeah.
that number.
So you mean
I'm gonna
100 Earths arranged, like
it's made around
like a round disc like
a
that,
flower,
right?
Oh, yeah.
So then
Um,
so then 100 times 80, so 8,000 millionths.
Millions of the sun. I like that number, but I'm gonna go slightly larger just for fun. So I'm gonna go 10,000 units.
It is 5,000.
Oh, I should have gone smaller.
Although
pretty
I
good.
found sort of conflicting numbers. I also had a 6,000, so it sort of depended on which reference we were
You're
looking at.
close.
But you both did great.
Thanks.
Yeah.
Right order of magnitude.
So
That's a big sunspot.
yeah. So it's something that would take. What was the number? 100 Earths.
100 Earths.
Tens of Earths to cover it,
Yeah.
basically in size.
Wow.
So that's pretty huge, and it's a ridiculous unit to use.
How many Jupiters is that?
Jupiter is 10 times the diameter of the Earth, so it's 100 Earths to cover Jupiter, so it's a Jupiter.
A Jupiter-ish.
One Jupiter.
Wow.
About one Jupiter.
A Jupiter spot.
Yeah. While it may have felt like
Cool.
weathering a dust storm on Mars, it was just another episode of Walkabout the Galaxy. Give us 5 stars or 5,000 millionths, and we'll give you the universe. Thank you, Katariina Nykyri. I probably didn't do it as well that time. Professor of Physical Science at Emory-Riddle University, for joining us today.
Thank you.
Be sure to follow us on Facebook and Instagram to get all our updates, and check out our website at walkaboutthegalaxy.com. Subscribe to our YouTube channel. Our videos now feature chapter markers, so you can skip to the good stuff, whatever that may mean to you. Catch up on old episodes wherever you get your podcasts. Follow us on Twitter
At walk_the_galaxy.
and ask us questions anywhere using #AskWTG. Our theme music was composed by Richard Jerusik. Production assistance is provided by Logan Basinger. Thanks to our listeners in Finland
Yay.
and around the world. Stay safe. I'm Josh Caldwell.
And I'm Addie Dove.
We're the astroquarks, signing off until the next episode of Walkabout the Galaxy.